Although often used interchangeably with short-term memory, a different conception, a different construct is that of working memory. So the idea of working memory emerged in the field after Baddeley and Hitch realized that the single store short-term memory proposed by Atkins and Schifrin didn't fully characterize all the aspects of short-term memory. For example, you'll remember that according to the Atkins and Schifrin model, there is a process of attention that determines what makes it into short-term memory from the sensory buffer. And there's another sense in which attention is also very important to eventually lead information into the long-term store and also to recover information from long-term memory back into short-term memory. And see, Baddeley and Hitch realized that although all these roles were attributed to the short-term memory store, these were not actually implemented. So in a sense, there was an implicit operational role assigned to the short-term memory store, but it was not overtly discussed. It was not really captured by the theory. And the nail in the coffin of that view, according to Baddeley, was the neuropsychological work of Tim Challis and Warrington in the 1970s. They extensively studied a boy who, by all standards, had a grossly impaired short-term memory. So, for example, his digit span was 2, so he could only recall two items. And yet, many other processes, such as his attentional processes, were perfectly fine. Now, if indeed short-term memory, if all these processes, as held by the Atkins and Schifrin model, were all into one store in a unified manner, then because he had this impairment, this kid should also have had an impairment in attentional control of information and things like that. And storage just sort of flows into short-term memory and then flows into long-term memory and recall. However, that was not the case. And so Baddeley set out to craft a model that was better suited to capturing these observations, and specifically a model that would be a multi-component system. So a model that would be fragmented into different aspects and not just sort of that you couldn't reduce to one single store. And Baddeley used the word working memory to capture this collection of different and separable processes that operate on short-term held information. In fact, the model that was envisioned is a model in which verbal / phonological information and visual / spatial representations were held separately in different and separable stores and were managed and manipulated with the help of attention-related processes, which, however, themselves were a different aspect, a different section of this store, so an independent function. And they termed this latter mechanism the central executive. And what you're seeing here is the original implementation of this model. So there's the central executive, which coordinates essentially information between the phonological loop and the visual spatial sketchpad. One important aspect, and I'll highlight it in just a second, one important aspect of this model is that whereas short-term memory is mostly described as a short-term repository for information, you hold it there. I give you a telephone number and you hold it there. At best, you rehearse it, and that helps you hold it there. Baddeley, instead, also assigned to working memory a more active process, not only of maintaining, but also of manipulating. So if I were to ask you, I were to give you a string of letters and I were to ask you to change their order according to some other rule, it would fall within the functions of working memory to manipulate that string to the end that the task requires. So one simple way of seeing a crucial difference between the two models, not only that one is a single store and the other one is a collection of processes that are separable, But one is really just very passive, whereas the other one includes this more active aspect to it. So looking at the so-called slave systems, the visuospatial sketchpad is the visual portion of short-term memory. This means that information about position and visual properties of objects are held in the store and are manipulated in this store. One example would be if I were to ask you to close your eyes and imagine rearranging the position of the furniture in your room, that active, not only the idea of conjuring that visual spatial information would be sort of the retrieval from long-term memory into short-term memory, in fact, in the visual spatial sketchpad of that information where you can hold it. And then the manipulation would also happen inside of the visual sketchpad. The second slave system instead is the phonological loop, which is responsible for dealing with auditory and verbal information, phone numbers, or as you're listening to someone else speak, that's where verbal information is deposited in the short term. So this is the auditory portion of short-term memory, and really it allows information to be held and manipulated. Here too, the phonological loop is divided into these two different aspects. On the one hand, a phonological store that can hold on to sounds for some brief amount of time, perhaps just about in the ballpark of 2 seconds, unless you rehearse, in which case you can hold it more. And you can think of the phonological store much like your inner ear. Kind of when you heard something and it's still there, and you can sort of, the information remains in there. I give you a telephone number and you can sort of hear it in your mind. That would be the phonological store. The other aspect to it, so this is the passive maintenance. The other aspect is the active manipulation of something. And this would be within the articulatory loop. So this allows you to repeat covertly inside your mind auditory or verbal information. In a sense, the phonological store kind of holds on to the information. The auditory loop, which is a bit like your inner voice, if you want, it can replay that for you. Much like if I were to give you a telephone number to remember, until you can write it down, you'd probably repeat it in your own mind, and that is the job of the articulatory loop. Now, a good question is, well, great. What a wonderful theory. But what is the evidence that there actually are these two separate slave systems inside our mind? And perhaps the principal piece of evidence at the time that it was formulated came from Conrad and Hall in 1964. And see, they found that when they gave participants lists of letters to remember, they would seem to have much more difficulty to remember the lists if the letters in the list sounded similar. So if the lists were comprised of B, T, P, V, C, recalling in order that list was actually harder than if the letters didn't sound similar, as in the case of R, W, Y, K, F. And so this is what Conrad termed acoustic confusion. When things are similar in short-term memory, you tend to confuse them. So this led to the view that in the short period, the code within which you're maintaining memories is acoustic. The format is acoustic. Now, so that's the evidence for the existence of this format. But there's also evidence for the importance and the fact that verbal rehearsal, vocal rehearsal is also an important component. Of course, you'll remember the Peterson 1959 experiment with the trigrams. And you remember that if you had to count backwards by 3, that would hurt your ability to recall over more than 15 seconds a trigram. And in a similar experiment, Murray used this so-called articulatory suppression technique, which is when you ask someone, again, I give you a trigram and then I ask you to just repeat some irrelevant word like the word the. And again, just like in Peterson, this impairs the short-term memory. And finally, Badley in 75 demonstrated the so-called word length effect. Now, the idea is that the retention, how well you can retain a sequence of words, is dependent on the length of the words. So if I give you a list of 5 monosyllabic words, then 90% of the time you are able to recall in the proper order all 5 words. But if I were to give you a list of 5 5-syllable words, then that goes down to 50%. So the idea is that longer word sequences took longer to articulate, and the function, the pattern of response suggests that the memory span that we have is just about whatever you can repeat in the span of a couple seconds. Now, a wonderful demonstration, or rather really dissociation of these two aspects, this duality to our maintenance of information over the short term, was published by Brooks in 1968. Now, Brooks did something very clever. He had participants do 2 different tasks, a verbal and a visual. And then he also had participants in both tasks respond half of the times with a verbal type response and half the time with a visual type response. Let me show you what the tasks were. So the verbal task would be you'd listen to a sentence, or you'd have to repeat in your mind a sentence. And you'd have to decide for each word if it is a noun or if it's not a noun. So very, very verbal task. On the other hand, the visual task would be that I'd tell you a letter, and you would have to imagine yourself at the bottom left of that letter, the bottom left corner of that letter. And then you have to navigate in this direction through it. And at every corner, you'd have to say, is this an extreme corner, or is this not an extreme corner? So is it an internal corner? I guess it would be something like, I think, extreme, 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 not extreme, not extreme, 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 not extreme, extreme. Now, as I said, for both tasks, half the times they had to respond with a verbal response. So they just have to say yes or no, whether it's the verbal task or the visual task. Half the times they would have to point at the answer on a grid. So they'd be provided with this grid of yeses and nos, and they'd have to point, at every word. They would point first word, second word, third word, fourth word. They would point at one of these two, one of these two, one of these two. Same for the visual task. They'd have to point at either the yes or no, or the yes, or for the first corner, then for the second corner, third corner, et cetera, et cetera. So the idea is that if these two aspects of short-term memory are separate, then if I do a verbal task and I respond with a verbal response, the two are interfering because they are the same system. If instead I do a verbal task and I respond with a visual response, because the hypothesis is these are separate systems, then the two should not interfere. Of course, if the two do interfere, verbal and visual, then it means that it's just one big system. It can't be two dissociated systems. In the same way, if I do a visual task and I respond with a visual response, obviously it will interfere, whichever theory you believe. But the working memory theory predicts that if I do the visual memory and verbal response, the two should not interfere much. Conversely, you'd imagine that the short term, the standard modal model of memory would imagine that because short-term memory is just one big store, visual task and verbal response should interfere just the same. And the results fall exactly in favor of working memory. As you're seeing here, if you do the verbal task and you respond with a verbal response, it takes you just about 14 seconds to respond. Conversely, if you do a verbal task, but you respond by pointing, it takes you less, which means there's less interference. Even more striking, if you look at the visual task, so the block letter, if you do the visual task, but you respond verbally, so you do this task, but you say yes, 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 no, it doesn't take you very long. It takes you about 11 seconds. But if you do the exact same task, but have to respond by pointing at a piece of paper with yeses and no on them, then it takes you much, much longer. In fact, I guess 28 or 29 seconds. So very clearly, there's a pattern where a task and a response interfere if they're in the same modality and don't interfere if they're not in the same modality. So this supports the idea that there have to be separate stores. If it were just one big store, like Atkins and Shiffrin said, then the two, these should interfere equally because they're all part of one store. Instead, they interfere selectively if they are in the same format. So this means that there must be a dissociation between processes and stores for verbal and acoustic information versus visual and visuospatial information. Now, finally, the last piece of the puzzle, or the one to last, as I'll explain in a moment, is the central executive. Now, the central executive is entirely novel to the idea of the working memory model. It kind of was implicitly in the short-term memory, the Atkins and Shiffrin approach. It just wasn't sort of explicitly formulated and distinguished from everything else. Now, the idea is that it connects the phonological loop and the visuospatial sketchpad and coordinates their activity. And it is also the link that regulates inflow and outflow of information from short-term memory or working memory into long-term memory. Now, this was the original conception of the working memory model. Nonetheless, around the year 2000, 2002, if I remember correctly, Baddeley added a third slave system. So this would be a sister system to the phonological loop and the visuospatial sketchpad, which he termed the episodic buffer. Now, he viewed this as a purely passive system, so it didn't quite manipulate things, but it held multi-dimensional representations. So you can think of it as your experience has different aspects to it, including a visual and an acoustic aspect. And these would be merged, would be bound together. And the episodic buffer held the bound representation. To be clear, the binding probably happens elsewhere. According to Baddeley, again, originally he thought the binding happened in the episodic buffer. The more recent 2012 on, if I remember correctly, theory is that the episodic buffer just is a multi-dimensional space that holds the information that has been bound elsewhere into one unified unit of meaning. Importantly, though, probably the key aspect of the episodic buffer is that is the contents that is likely to be associated with the contents of what you are consciously aware of. And in fact, probably your consciousness of what's in the phonological loop and in the visuospatial sketchpad might be mediated by the episodic buffer. And in fact, the current model looks something like this. The central executive perhaps mediates directly or interacts directly with the episodic buffer, and the episodic buffer draws from the sketchpad and the loop and holds on to a unified, coherent, chunked, meaningful representation. And that might be either the focus of your attention, although it's contentious whether the two are the same or not, but that probably is the contents of your consciousness.